Friends, more than 400 rivers traverse the length and breadth of India, forming the 8 major river basins or river systems such as Ganga, Yamuna, Narmada, Tapati, Godavari, Krishna, Indus and Brahmaputra. They sustain our lives by providing irrigation, drinking water, transportation, power and grant livelihoods to a large population, besides being an inseparable part of our religion. Yet, we have severe drought-prone regions and parched fields. Can we have a river grid that would support or supply water to all regions by diverting the excess water to parched rivers through a network of rivers? Let's find some answers to this interesting question this Saturday. Whereas Ganga flows for 2,525 kilometers, Godavari for 1,464 kilometers, Yamuna flows for 1,376 kilometers, Narmada for 1,312 kilometers, Krishna for 1,300 kilometers, Indus and Brahmaputra originating in other countries flow for over 1,114 kilometers and 916 kilometers across in India. All these originate from the Himalayas and the Karakoram range or the Chota Nagpur plateau and Vindhya and Satpura range or the mighty Western Ghats. Now that's the beginning. Even as most of the rivers discharge into the Bay of Bengal, some flow through the western part of the country and discharge into the Arabian Sea. However, the Aravalli range, some parts of Ladakh, and arid regions of the Thar Desert have inland drainage. They don't flow into the seas. Even as our river system is extensive, it's an irony that we cannot provide safe and clean drinking water, to everyone. Even our irrigation water supplies for sustainable agriculture is in shortage. Our water resource essentially is due to precipitation, surface and groundwater storage. We get an average precipitation of 46 inches per year of rains in 80% of the total area annually, or about 1,720 cubic meters of fresh water per person every year. Other than rains, melting snow in the Himalayas in winter feeds the northern rivers to different degrees, varying degrees. We account for about 4% of the world's water resources. A person in India needs about 1,500 cubic meters of water every year. Now, even as the need is much less than what we receive, everyone does not have sufficient water in the country. Why is this so? The answer is much of what we receive flows into the seas and what we use into the nalas as waste. Though it is true that the rain we receive is not uniform in time or geography, occurring as it is in the months of June to September, it doesn't spread across the year. Combined with melting snow in winter, it causes flow variability, leading to flooding in some months and water scarcity in other months and drought in others. Whereas Indo-Gangetic plain suffers from floods due to rains and melting of glaciers, the peninsular states suffered from droughts. Does the answer to the problem lie in moving water across rivers in a network of reservoirs, dams, canals, or to effectively manage the water resources better? Can that be a solution? Though the idea of interlinking rivers is an old idea, its implementation has several challenges. And its implementation is not old. Is this a technological challenge? Is this an environmental challenge? Probably both. That such a project is being envisaged by Government of India is very welcome. It is the creation of a massive Indian water grid through the transfer of water from water excess basin to the water deficient basin. Now, realizing it means interlinking 37 rivers by a network of more than 3,000 storage dams. Look at the topography. Somewhere you may have to raise the water, somewhere you may have to lower the water. That's a massive challenge. Then the Ken-Betwa link project is the first under the National Perspective Plan for the interlinking of rivers, where water from Ken, a tributary of Yamuna, will be moved to Betwa, another tributary of the same Yamuna, could be a test case for future efforts. Interlinking rivers could enhance irrigation and groundwater recharge, reduce persistent floods in some parts and water shortages in other parts. This project is expected to provide annual irrigation of 10.5 lakh hectares, drinking water supply to about 60 lakh people, and also generate 100 megawatts of hydropower. The water grid, when ready, could generate about 34,000 megawatts of electricity. All that is in the theory. Economics of it is more interesting. The power required to lift the water for hydropower is likely to be more than what it might actually generate. 1 megawatt of hydropower costs over 10 crore rupees and produces less than 4 million units of electricity, which amounts to per watt cost of about rupees 8. Reality, however, is that there are no takers for power that costs even at rupees 3 per unit. So how do we make this work? Ideally, the project will ensure a minimum amount of water flow into the rivers, greatly helping in the control of pollution, in navigation, forests, fisheries, and wildlife protection. Since an improvement accrues in the inland waterways transport system, the rural people could explore an alternate source of income in the form of fish farming. Do challenges outweigh the opportunities? Now, this is a project that has to be researched, and researched when. What are the challenges? First, the cost. Estimated to cost almost 6 lakh crore rupees. Delays and unforeseen challenges could double that figure. Second, the engineering of structures at various elevations and terrains can be an engineer's nightmare. However, massive employment opportunities that accrue is the brighter side. The environmental impact is too serious, even as it is sensitive. Now, wildlife, flora, fauna of the river systems will be displaced, affecting the delicate ecosystems that prevail. Since many national parks and sanctuaries are, integrated within the river systems, they would be adversely affected. Will the project reduce the flow of fresh water into the sea, affecting the marine aquatic life? That will be a study for research. Building dams and reservoirs will cause displacement of people, around that place. The mental agony that they might undergo may be mitigated, through appropriate rehabilitation and an adequate compensation. But will that suffice? Will that assuage the feelings of people displaced? Further, building dams may not always mitigate floods. Theoretically they do. However, there are any number of examples to the contrary. Hirapur Dam, Damodar Dam have actually brought floods to Odisha and West Bengal in the past. Getting all the states to agree to interlinking can itself prove a challenge, given the interstate river disputes that we have. When building dams and reservoirs is expanded to the Himalayan component of the project, we could even have disputes with the neighboring countries. In as much as saying interlinking of rivers is an idea worth exploring, it entails a large number of dams that will lead to destruction of rivers, forests, wetlands and local water bodies, which are major groundwater recharge mechanisms. Probably better irrigation practices and watershed management is what we need. Even the National Waterways Project, which uses only the excess flood water that goes into the sea unexploited, could be a way out. Mark Twain said, "The river has great potential, great wisdom, and whispers its secrets into the hearts of men. Should we not seek those whispers?" So friends, I will end with this episode this Saturday and urge all of you to spend a few minutes to ponder on what I have presented today. Rivers are like our mothers. Let's protect them. With that, let me say thank you and with a promise to return back the next Saturday. Until then, Dhanyavad and Namaskar.